What's CMR, by the way? Since
Common
you
mode.
mentioned. Yes, what's that?
It's the ratio to reject the noise or something like that, right?
Yes, being more specific. It got nothing to do with reject the noise. What's the definition? Exact definition. CMR, since you mentioned.
Measure ability of amplifier to amplify desired differential mode input signal.
Yes. So in short, it is actually,
They want the differential but don't want the common mode.
yes, in short, it's just like what we mentioned just now. We want the differential signal to be amplified and we want to attenuate the common mode signal, right? So if you remember what we talked about previously, the circuit seen by your AC and DC, they're actually different, right? Your DC CD circuit like this, but for your AC, you will see another way, right? So for your common mode signal and differential mode signal, it also behaves similarly like that. So your common mode signal, after your common mode signal passing through whatever this circuit, okay, after it be amplified, blah, 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 it will appear at the two outputs together with your useful AC signal. But the difference is the gain it gain after passing through this amplifier is different from that of your differential signal. For example, you have a 5-volt differential signal input, and the gain seen by this 5-volt differential signal input signal will be 100. So after this 5-volt passing through this amplifier, it will become 500 volt. Okay? And the common mode signal, if it is also 5-volt, appearing at these two input nodes, but again, it can gain from this circuit is maybe, for example, only 10. So after your common mode signal passing through this circuit, it will become 50. So the common mode signal appearing at the output of your differential amplifier will be 50, but the differential mode signal appearing at your output will be 500. Okay, so your CMRR is actually the ratio of the two gains. The gain fueled by a common mode signal over the gain. Which one over which one?
Differential over common.
Okay, so it's the gain fueled by your differential signal over the gain of your common mode signal. So how to calculate this one? It is actually your calculate the differential gain first. Then you calculate the common mode gain. Then you just take the ratio. That's a CMR. Okay, so that's some background knowledge, I would say. Okay, there's some background knowledge and can be applied to all kinds of amplifier, not necessarily for differential amplifier only. But just now we are talking about the analysis method, right? What's the name for your analysis method? What's the name for the method? There are two methods introduced by the lecturer inside the notes, but in practice we only use one method because the other is too complicated and it is too time consuming.
In the half circuit.
Yes. So the name for this analysis method is what?
Half circuit.
Half circuit. What's half circuit? Half of the circuit. Okay. What do you mean by half of the circuit?
I just do one side.
Okay, so it's left, right, or
Left,
up, down?
left,
Left and right. Okay, so basically is we only do one half of the circuit. Okay, so why can we do that?
symmetrical.
Because this circuit is symmetrical, so we can do the half circuit. Okay, you don't do half circuit for other circuit. Okay. For this course, you only do half circuit for your differential amplifier. So what are all those rules you must obey in order to do this half circuit analysis? Half circuit analysis method is a method, okay? It is not in the same category as your AC DC analysis. AC DC we are talking when we're talking about the signal, the input signal is AC or DC. There are two modes, okay, AC analysis and DC analysis. And this half circuit is just the name of one of the circuit analysis methods. So what are all those rules?
So that means for half circuit, there's no AC or DC.
For half circuit you can do AC, you can do DC, you can do DC, you can do AC. Half circuit is just a method you can apply when you are trying to analyze your differential amplifier. Let's say, for example, now I want to know the DC biasing for a differential amplifier. I can use this half circuit method. And then after I do my DC analysis, I get my Q point. I want to do my AC analysis, I can also use this half circuit method. It's just a method. Okay, so what are all those rules we must obey in order to use this method?
Common ground.
Got 4.
Voltage and current no change.
What do you mean by voltage and current no change?
Then they remain the same. They remain the same.
The first step is what? In order to do your half circuit analysis, first step, you need to
Split that into half.
split the circuit, right? So first step is split your circuit. How to split left and right? Okay, so you just split your circuit into 2 parts. So you just split your circuit into 2 parts. Okay, left and right. So this dotted line is just we draw the symmetrical line, right? But actually when we want to separate them, what do you mean by separate? Separate is like, I draw this part of circuit as one individual circuit and this part as another individual circuit. So how to draw them into the individual circuits?
The visual voltage will remain the same. Then the resistor divided by 2.
Voltage source remains the same.
Yeah,
And?
Resistor divided by 2.
Which voltage source? You got 3 voltage sources for one side. For each side, you got 3.
VCC.
Minus V is a voltage source. VCC is a voltage source. This one is also a voltage source. Okay. So how to split?
V and VCC remain the same.
You don't just look at the white wall, search your notes, okay? How to split?
V split into 2, then the
V split into 2. How about the value?
the value is the same, but then the resistor must put 2R.
Okay. So by saying that, you are actually doing what? Which mode? Common mode, right? Because common mode include your DC analysis, right? Okay. So only in DC analysis we care about this minus VEE plus VCC, right? Because in AC analysis, these 2 DC sources are AC ground. Okay, so in AC analysis, we don't really care about these 2 sources. So just now what you're talking about is actually common mode. Okay, so when doing your common mode analysis, we will split a circuit. We just split DC sources. Okay. That means I'm going to have this one. I'm going to have this one. This is one side, okay. So I'm going to have this one. I will have separate VCC and minus VEE. How about these two resistors? This one should be
RC.
RC. Why?
Because both of them got the same.
Okay, this one is just your copy, right? This resistor is not affected by this separation. Okay, it is there. Okay, so you just copy. Here is your RC. How about this one? This resistor originally it is your REE, but now when we separate the circuit, it will be affected by this separation, right? So how are you going to change your REE
Why?
to REE? Why?
So we combine them in parallel, you become one.
Yes, because if you draw the other half, the other half you also got this resistor. So if the value is 2 REE, these two in parallel will give you original REEs. Okay, so this is the Coleman mode, how you separate your circuit if you want to do Coleman mode analysis, if the input signal are Coleman mode. Okay, so for Coleman mode, you split the both DC sources and resistor along the line of symmetry. Resistor along the line of symmetry
Double.
is also splitted into 2 times the original value. It's inside a note. So that's your Coleman mode. So if now I'm going to do my differential mode, if the now my input two input signal are actually differential mode signal, then how should I split my circuit?
The DC sources are ground.
Again,
The,
No?
the DC source.
the DC source is ground. Okay, so this one ground, this one ground, this one ground, this one ground. Okay. So when we want to do the differential mode, for this course, differential mode only apply to AC signal, AC input signals, right? So whatever rules you need to obey when doing your AC analysis, you also need to apply here. Okay. So this one, this grounded thing is actually coming from your AC analysis. It is actually not the rule of your half circuit analysis method. Half circuit is about how we split the two, how we split your differential amplifier. Okay, so after doing this, how we split the circuit? How to split the circuit? I ground this one, I ground this one. Then, how about here? Here, here, and here. What should I put here? In these 4 positions.
Virtual
These
ground.
these two transistors we just copy, right? Because it's just like you just copy. Okay. These two just copy. How about the four blanks? Here is here?
It should be like a virtual ground.
Should I put it here?
RC.
How is it?
It's a R
RC.
C. Here is also RC. Why? Because originally my two side got this RC, so they are not affected by my separation. It's not along the line of symmetry, right? So it will not be affected, so you just copy RC. How about here? Don't have. What do you mean don't have? What should I connect here? Cannot just
I mean,
make this terminal.
short.
Just directly ground.
Okay. So you are saying for this terminal, I should ignore this resistor and I just connect it to the ground. Why?
V equals 0. V is 0.
V?
E.
E. Here is V. 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 V here. Here.
Yeah.
V. E. V is
0.
why?
Natural ground.
Why?
Because the source was initially a DC source. And now we are doing AC.
What? No. Why it is a virtual ground?
Cause IC1 minus IC2 equals 0.
Again?
IC1 minus IC2 equals 0.
Got something to do with that.
Then from IC3 to IE.
I only asked for some general idea. Because actually this virtual ground can be proved by all the derivation. You expand the circuit, blah, 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 then you do your AC analysis, you can prove this node is a virtual ground. Okay? And now I'm only asking for a general idea. You need to, although you may need really understand how to derive this part, but I think you can understand, and if you really go back and read the derivation, you can understand, but it will take some time. Okay? So I only ask for some general ideas why this node is a virtual ground. You need to have this kind of background knowledge so that you can, when we talk about this circuit, you can explain to your friend.
Where there's no current flowing through REE.
What do you mean by yes? If there is no current flowing through REE, by Ohm's law, this node will also be ground, right? Because for differential mode analysis, which is also a AC analysis, this node is ground. Okay, so in order for this node to be ground, the current flowing through this RE must be 0, right? That means there is no voltage difference across this RE. Okay, so the current flowing through this RE is also 0, which means that if you look at this node got 3 branches, right? Left, right, down. By your KCL? KCL is saying whatever going in equals to whatever going out, right? So what we want is this branch, the current is 0. But how about these two?
They are the same, so they cancel each other.
These two, the current cannot be 0. These two must carry some current. Otherwise this current coming out of your transistor got now nowhere to go. So definitely here goes some current, here goes some current. But these two current will be the same. The value will be the same, but the direction will be
Into
Opposite.
one is into this node, one is off this node. Okay? So now the question becomes, why can I say these two currents are definitely the same?
because they are symmetrical.
What do you mean by symmetrical?
Both sides are the same.
What do you mean both sides are the same?
The input source is one is PID over 2, and the other is it's the same lah. The input source.
No, they are not the same.
One is positive, one is negative.
Yes, so?
So that they minus them.
Positive, negative actually affect what? Polarity only affects your direction, your current direction. Okay? The value is the same. Let's say, for example, here is 5 volt, here is minus 5 volt. Whatever AC analysis you do here, you will realize all the current flowing through this part, the value will actually the same as the current flowing through this part. All the values are the same, but the direction will be opposite. So that means what? Current going out of this emitter will actually equals to the current going into this emitter. Because these two input sources are opposite, right? The polarity. So if this input source give a current going out of this emitter, this input source will give a current going into this emitter. And because of their value are the same. So these two current, the value will be the same. Okay? So we can say that whatever current flowing into this node will be whatever current flowing out of this node. That's why we can say there is no current flowing through this branch. That's why we can say here is your virtual ground. That's the general idea. If you don't believe, you can go back and derive. You can derive, you just you just redraw these two transistors into their hybrid pi model, equivalent hybrid pi model. Then you just analyze the whole circuit using the same method we introduced in the single transistor amplifier. Then you can see actually these two currents are the same and their direction are opposite. That's the knowledge you must know. That's the background knowledge. Okay? Here is your virtual ground. So here I can just put it as a ground. Question for this part? I think at least got one confusing point for this part. At least got one confusing point for whatever I explained before for this part. Question? No question. Why my IE can go out of my emitter and go into my emitter? Let's say this VID is giving IE going out of this emitter. This VID, this minus VID over 2 will give another current going IE going into this emitter. Why can my IE go into this emitter? Why can IE go into the emitter? Is that possible? Is that possible? Is that wrong? Can my IE go into and out of the emitter?
Can.
Can. Can or cannot? Can. Why?
Is it because originally the base at Q2 is connected to the Q1?
Again?
The base at Q2 is connected to the base of Q1.
No.
Like
Yeah. It is one, it is one stereotype because when we talk about DC analysis, we say that the current direction, the three currents, IB, IC, IE for BJT, okay, the direction of the current is actually depending on the arrow direction, right? Look at the symbol of the arrow. So your IE is going, for NPN, the IE is going out. For PNP, the IE is going in. Okay? That's only for your DC analysis. You don't confuse the DC with your AC. Your AC current direction does not necessarily follow the arrow direction, the symbol arrow direction. Okay, because your AC, how your AC see this transistor? Your AC do not see your transistor like this, right? It actually see your transistor like the hybrid pi model, right? That's what your AC see. It will never see your transistor like this, so you will never see this arrow. all you can see is your hybrid pi model. Okay, so if you replace this transistor by its hybrid pi model, the hybrid pi model, there's a current source inside hybrid pi model, right? The direction of the current source is fixed. Okay, so you just replace this transistor with the hybrid pi model. Then you change the hybrid pi model input to this number, to this negative number. You will realize that actually your IE is flowing into your emitter. It is because of this input polarity.
See, because like positive and negative, then I will just go. Like positive to negative.
What do you mean by positive to negative?
So this side is negative. This side is positive. So current flow from the positive side to the negative side.
It's like when you do AC analysis, you redraw the circuit into its AC equivalent form. If the input is this one, you will get all the current direction and all the voltages, right? But if you reverse the sign of your input source, you will realize that all the current direction reverse as well. That's all. That's AC. You don't confuse the AC with DC. And don't ask the lecturer why my IE can go into the emitter, it can't. Okay? Because we are talking about AC. So, to summarize for your differential mode, is what? The first step is ground DC sources and point along line of symmetry points, all the points along the line of symmetry are
Connected to virtual ground.
virtual ground. Virtual grounded. It's inside and out. You don't really need to copy. And all the rest components, the rest of the circuit which are not along this line of symmetry, you just copy. Okay, you just copy accordingly. All the values, blah, blah, blah. Because they are not along the line of symmetry, they will not be affected by a separation.